Okay, so next Tuesday, we will not have lecture. We always have this at the end of the course, which is a lecture given by Keith Baggerly from MD Anderson, where he talked about reproducible research. This is related to a major scientific plagiarism or scientific dishonest issue, which really started NIH requiring data and code to be made public so others can reproduce the results. I hope you all learn from this experience. Data fabrication is a betrayal of your career, and a lot of those can be digged out later, which is something we should never think about to do in our career. And in this case, you can see patient can be hurt. And this is a very, very serious issue. And for this course, because of COVID-19 this year, we're not going to have a final exam. We're only going to do grading based on satisfactory or unsatisfactory from the 6 homework. I know students are working really hard. We look at the survey, every homework. I think on average, students are spending 17, 20 hours, and some students even spending more time on this homework. I think that's a good enough way for us to evaluate whether you have learned enough to earn a satisfactory grade. And so don't worry about this. And I hope even if it's satisfactory, unsatisfactory, you will still attempt to do homework 6, not to say, well, I'm done, I get a satisfactory grade, and I don't need to learn the last part anymore. It's a very useful course. Every homework we put in good thoughts to develop. So these are good skills that you can use later in your career. And please help us fill out the course evaluation. And also homework 6 still have a survey. We want to learn whether we're making homework well every year. We do reuse significant amount of homework in this course. So that's why we cannot give students the full solution every year. I hope you appreciate in some of these homeworks, we want to make sure all the different questions from the beginning to the end, using one data set, they all have to fit. If you look at any nature or science paper, using existing tools, you will find a lot of times the results just wouldn't fit using existing tools. You have to tweak the tools, you try different parameters, you try many different things, you have to write your own code, some of the tools work and then other ones are not really commonly used tools, and then finally you get this hypothesis. It's not easy. So we are trying to use public data and also the most widely used tools to teach you. This is roughly how people think about this problem. It's not easy, and we try very hard. And also some questions, when we feel that students are struggling, we try to make some new questions every year, but we can't possibly make brand new homeworks every year. If you want to try it out, take a Nature Science paper now. See whether, based on the description of the paper, you can use the existing tools. I think you can get a lot of very useful results, but maybe or maybe not, you may or may not be able to reach all the conclusions reached by those papers. Some of them may be because of your limited bioinformatics skills, but others could also indicate that those hits or the conclusions might be wrong. So, I mean, I think hopefully you will have enough skills that will carry you for a long time. So the remaining one is the final exam practice that we gave from the previous year. That we did not change any questions, and also because this year we did not have a final exam, I'm just going to leave this to last year's video. So please watch last year's video. I hope that in this course, you don't just use the tools, because in the homework, we teach you exactly, you get this, you run this, you get this, you run this. But look at the final questions, especially those major questions, long answer questions. If your collaborator gives you this data, how do you approach this problem? You can think, maybe I'll just go to the very end in the scenario, which is anytime you have high throughput data from your collaborator, you start by doing quality control and pre-processing of some data. Then you do the comparison, your treatment control, responder, non-responder, progenitor cell versus differentiated cells or whatever. You do some comparisons, and then you try to do some pathway analysis. You try to check other cohorts. My data might be generated on a mouse or on a cell line. Does it work in light of many other data in the public to help you prune and refine your hypothesis? That's the general approach that we all do, at least we do as a computational biologist. And so a lot of these long questions, in a scenario, you have this data, what do you do? Think about what are the QC measures? What are the comparisons that are meaningful? And then how can I use public data to really help me prove my hypothesis? Okay, so at the end, I want to use this quote from Sidney Brenner, who is an experimental biologist, the 2002 Nobel laureate, and he says, all biology is becoming computational, much the same way it has become molecular. Otherwise, you have low input. So, by the way, in the 1980s, all the biologists are trying to use molecular biology. It's so powerful. And now everybody is doing genomics. And if you have genomics, there is no genomics without bioinformatics. Computational biology is becoming more and more important. If you don't know this well, then it will become low input, which means you don't think before you do a high throughput experiment. And then high throughput, it means you are generating a lot of genomic data, and then no output, meaning after you get the data, there's no real finding, no new knowledge gained. So computational biology is really important to make sure that genomic science are done correctly and done well, cost effectively. So I hope you continue to learn computational biology. It's a skill you can continue to hone over time, and hopefully that will help you with your discoveries. And thank you so much for taking this course. It's a privilege for me to teach you in this semester, and I wish everybody a good spring and stay safe. Bye.
Sorry, Professor, just one question about grading. It seems like we do not have letter grade anymore, or is that like we still do letter grade like A, B, C?
No, there's no letter grade. Graduate school and undergraduate school all decided to just have satisfactory, unsatisfactory, all default now.
That is not the case for some of the grad programs, at least not for the medical school, biomedical informatics. We were able to opt in, but we didn't have to necessarily do it.
That's also true for me.
Well, that's good to know. Well, so we will still use the previous curve, which actually this year will be beneficial because the rest of the students may not work as hard in the 6 homework. You might be top of the class.
So I'm in the School of Public Health, and
I see. Sorry, I didn't know that.
Okay. So we don't have to So my question is if I still stick to a letter grade, which is what I plan to do now.
Yeah, sure. I think that would be great. We will actually give everybody a letter, except that by the time we enter those grades, registrar might just change it to satisfactory, unsatisfactory.
Yeah, but for us it's optional, and I think for this
okay. We'll still grade you guys.
Yeah, I spend a lot of time, so I still hope to get an A. Well, I mean.
Okay. Yeah, definitely.
Yeah, thanks.
Okay, great. Bye-bye.
Bye.
Thank you.